Hello, everyone, and thanks for joining. It's Brian again, and this is session 2 of the DFMZ Lunch and Learn series. Last time, we talked about who DFMZ is and the 4 things every product we build is designed to protect. Today, we're staying inside one product line and going a lot deeper: automation enclosures. This one comes up constantly in the field because so much automated equipment ships with a standard off-the-shelf enclosure. Those can work fine for general applications, but they're not always built around the specific demands of a specialized laboratory environment. So that's what we'll dig into today: why a standard enclosure isn't always the right fit, when it makes sense to go custom, what to actually look for when you're specifying one, and what DFMZ builds into every automation enclosure by default. We've got a bit more time today, so let's get into it. Here's where we're headed. We'll start with the 2 questions that really determine which enclosure a given application needs. From there, we'll walk through the places standard enclosures tend to break down once real automation is running inside them, and what that actually ends up costing a customer. Then we'll get into what DFMZ builds in as standard, the configurations we offer, and a quick specification checklist you can bring into your next call. Let's get into it. In session 1, we covered the 4 things DFMZ protects at a company level. Today, we're narrowing in on automation enclosures specifically, and more importantly, on why a standard enclosure isn't always the right solution for a specialized lab environment. Standard enclosures are built for general purpose use, which makes them a reasonable fit for straightforward processes. But specialized automation often asks for more than a standard configuration can give it. Airflow configuration and control options tend to be limited, so the enclosure can adjust for custom airflow sequences based on door, sash, or pass-through position. Cable and utility pass-throughs are usually fixed instead of built around your equipment, and standard dimensions don't always make the best use of your lab space or match your equipment's footprint. On top of that, you may be dealing with specific building codes, facility standards, validation requirements, monitoring needs, or planned equipment upgrades down the road, all of which call for something more flexible than what comes off the shelf. That's where a custom engineered solution comes in. With DFMZ, the enclosure gets engineered around the process itself: airflow containment, product protection, exhaust requirements, automation and controls, utility routing, alarms, monitoring, and dimensions. But before we even get into configuration, there's one question that has to come first. How do you determine what type of protection the application actually needs? It really comes down to 2 questions. First, does the process need product protection? In other words, does the sample or process need to be shielded from surrounding aerosols or contamination? And second, does it need personnel or environmental protection? Meaning, does hazardous material or aerosol need to stay contained inside the work zone instead of escaping into the lab? If the answer to both is yes, or if personnel and environmental protection is the priority on its own, you are looking at a Class 2 enclosure. Depending on the application and the material being handled, that could mean type A1, A2, B1, or B2. Those types are not interchangeable. The right one depends on the material being handled, whether hazardous vapors or chemicals are present, and the exhaust configuration the application requires. A Class 2 cabinet gives you personnel protection through inward airflow and product protection through HEPA-filtered airflow at the same time. So it covers both cases. If product protection is the primary objective, a positive pressure HEPA-filtered enclosure may be appropriate, using filtered downflow to protect the work zone from surrounding contamination. And if the application needs neither product nor personnel protection, a bonnet or other basic enclosure can still add value simply by creating a controlled workspace around the automated process. The key takeaway: don't start with the enclosure, start with the application. Once you understand what needs to be protected, what the process requires, and how the equipment actually operates, the right enclosure type becomes a lot clearer, and everything else, airflow controls, Dimensions, utilities, monitoring gets engineered around that. Class 2 covers most of what we build, so it is worth knowing how the four types differ. All four give you personnel protection and product protection. What changes between them is how much air recirculates and where the rest of it goes. Type A1 recirculates most of the cabinet air back through HEPA filters and exhausts the rest into the room. That suits basic microbiological and tissue culture work, but it is not recommended for toxic chemicals or radionuclides. Type A2 is the one you will see most often. It recirculates about 70% of the air through internal HEPA filters and exhausts the other 30%, either into the room or outside the building. That covers most clinical lab, biotechnology, and pharmaceutical compounding work. Type B1 is for work that generates chemical vapors, as long as those vapors do not interfere with the work when they are recirculated, or the work is done in the directly exhausted part of the cabinet. And Type B2 is a total exhaust cabinet. Nothing recirculates. It is used in toxicology labs and similar work where chemical effluent is present and clean air is essential. The type follows the material being handled. Ask what the process generates before you talk about a cabinet. If a prospect cannot answer that, you have already found something useful, and it is the right point to bring us in. Before we get into where things can go wrong, it's worth pausing on what's actually included, because this is where DFMZ separates itself from a catalog box. Chemical resistance is built in from the start, with seam-welded polypropylene construction as standard, not an add-on. LED interior lighting comes standard too, with a UV light option if the application calls for it. Fans, lighting, and fan speed all run through a single touchscreen panel, so the airflow can be set to what the process needs and adjusted later if the equipment inside the enclosure changes. HEPA filtration is rated 99.99% efficient at 0.3 microns. And when combined with the appropriate airflow design and validated system performance, can support an ISO 5 work zone. That's a spec worth comparing closely against any other enclosure you're evaluating. And every build, from console to walk-in, comes with a full 1-year warranty on parts and labor. None of this is an upsell. This is the baseline. Worth keeping in mind the next time a prospect is comparing price against a bare catalog enclosure. So what happens when a customer skips all of that and buys a generic box instead? There are two areas where we consistently see standard enclosures fall short once real automation is running inside them. The first is contamination. A standard enclosure is designed around a general environment, not around the fine particulate or off-gassing that a specific piece of equipment generates continuously right at the work surface. The second is integration limits. Cable pass, throughs, service access, interlocks, and equipment interfaces often become afterthoughts on a catalog enclosure, which in the field usually means drilling, cutting, or modifying the enclosure just to make the equipment fit on their own. Either of these is an inconvenience. Together, they tend to create maintenance issues, performance problems, and costly modifications that could have been avoided at the design stage. That's the advantage of engineering the enclosure around the application from the beginning. We see projects where an enclosure has to be modified or replaced because the original design wasn't matched to the automation. Here's why this matters beyond engineering. It matters commercially. And this is your ammunition on a sales call. Start with unplanned downtime. When the enclosure isn't built for the job, it's rarely just the enclosure that goes down. It's the entire automated line behind it. Then there's rework and field fixes, the cutouts and modifications made to force a standard box around real equipment almost never hold up long term, so someone ends up doing the job twice. Voided warranties tend to be the one that surprises people. Field modifications can create warranty concerns, particularly when they affect the equipment interface, safety systems, airflow, or the manufacturer's specified installation, and that can involve equipment worth far more than the enclosure itself. And then there's compliance exposure. If the enclosure was part of a validated process, a poor integration can compromise the very airflow or containment that process was validated against, which turns into a much bigger conversation with quality and regulatory teams. None of these costs show up on the enclosure's price tag. They show up months later. That's the conversation worth having with a prospect before they buy the wrong box, not after. So how does DFMZ actually approach this differently? 4 steps, and the order matters. First, we map the equipment, footprint, cabling, and access points before anything gets designed. Second, we engineer the airflow around the actual application, building a custom air solution based on the equipment's footprint, contamination requirements, and the ISO level the process calls for, rather than dropping in a generic airflow configuration. That same step lets us account for unique requirements right from the start. So things like access panels, service points, equipment openings, and pass-throughs get built into the design instead of modified in later. Third, integration is built in from day one. Pass-throughs, interlocks, service access, and equipment interfaces are designed in, not cut in later with a hole saw. And fourth, everything is tested, documented, and prepared for the applicable certification and performance requirements. You'll see this same approach across every configuration we build: console and benchtop units for compact systems, walk-in enclosures for larger automated cells, and fully custom builds when the equipment's geometry demands it. Same engineering process every time, regardless of size. If you remember nothing else from today, remember these 3 questions. They work on any automation enclosure conversation, regardless of vendor. Airflow and filtration. Is it matched to what the process actually generates, particulate, fumes, or both? And does it use true HEPA filtration rated 99.99% efficient at 0.3 microns? With the airflow design and validated performance needed to support an ISO 5 work zone? Or is it a one-size-fits-all filter? Integration and access. Are cable pass-throughs, interlocks, and service access engineered in? Or will someone be modifying the enclosure on-site? And standards and certification. Is the build documented against the applicable certification or third-party testing requirements, such as TV or Intertech/ETL? Or is that an afterthought too? Ask a prospect these 3 questions about their current setup, and you'll usually know within 30 seconds whether they're sitting on a problem. So when a prospect asks why DFMZ instead of a catalog automation enclosure, here's the answer in 5 points. It starts with equipment. First, design. The automation drives the specification, not a standard SKU. Then there's the air first philosophy, the same principle from session 1. We engineer the airflow around the application instead of just building boxes. Compliance is built in with applicable standards and certifications considered and documented from day one, including applicable TV or Intertech/ETL certification requirements. We offer full scope solutions, console to walk in from a single vendor, which simplifies procurement and accountability. And every build comes with a full 1-year warranty on parts and labor, backed by Canadian manufacturing. That's the difference between buying a box and buying an engineered solution. So, can you say it in 1 sentence? Standard enclosures are built for a room. DFMZ engineers enclosures for the equipment, its airflow, and its integration. So the box is never the reason automation isn't built for the job. That's today's session. If you have any questions, drop them in the chat below. Our team is here and ready to answer your questions. For our next session, we'll cover clean rooms, DFMZ's full structure-controlled environments, built to any ISO level from the ground up. See you then.